General Protocol Spaces, Banking on Freedom.
Hello, everyone, and welcome to General Bull 43 of N. This one's going to be quite technical. It's about BitCANN. It's a new protocol proposal by one of our speakers here, by our co-host, Kuldeep. And it's also about, more generally, about smart contract audits, safety, trust, and awareness of how to deal with trust in contracts and protocols on Bitcoin Cash. So I expect this one to be quite technical. It should be fun. And it's actually, I think, a bit of a exploration of a space that we don't really have a full solution to. We don't know exactly what the solutions are to these things because smart contracts, protocols, all of these things have worked on Bitcoin Cash, but it's still not had an explosion of apps and protocols. And so there's some amount of unknown about how we're going to go about all this in a way that works on UTXO and Bitcoin Cash. So first, let me introduce some of the people who are here with us. There's Jim, who is doing, he's done an unlimited number of things, but right now he's especially working at General Protocols on the XO stack, which is going to make all of this kind of power of smart contracts and permissionless money available to developers, to app builders, and to users in wallets. And there's Mathieu, who is an entrepreneur, among other things, making use of BCH and also developing the CashScript language and compiler together with Roscoe, who may join us later, I'm not sure. And Roscoe is the guy who originally wrote the CashScript compiler and also makes revoke.cash, which originally was for ETH and now works on, I think, a lot of or all EVM chains. And Dagra with us, one of the oldest OG Bitcoin node developers from the days of the original Bitcoin XT and all of that. He's also more recently the co-developer of the Flipstarter crowdfunding protocol together with some of us at General Protocols. And now he's continuing the current work with pioneering UTXO-based DeFi on the Cauldron DEX, which maybe we can talk about because another one of the proposals that is in practice and working and doing significant volume. And finally, last but not least, Kuldeep Kiok, who has made the proposal, that's the main subject of our talk here, the BitCANN smart contract protocol on Bitcoin Cash. So I hope you guys don't mind my introductions in the to help us get through this quickly. And let me get straight into it with Kuldeep. So Kuldeep, could you tell us a little bit about BitCANN, kind of the scope of it, what it is, the protocols, the contracts? Could you give us a summary of what it is you've made?
Yeah, sure. First of all, thank you so much. I'm very excited to have this conversation with all of you. BitCANN is basically a domain name and an identity system that is built on top of Bitcoin Cash blockchain. So what it provides is that we can have such systems where, let's say, .sat, .bch, or such similar TLDs are easily possible using the system. And it also assures us that this particular domain, let's say kuldeep.bch, is not owned by anybody else. They are verified by how the system works. And anybody who has ultimately that NFT, because they can prove that they are indeed the owner of that domain. So what this allows us is that anybody who is the owner of this particular domain, they can add any of their records on blockchain, and that will allow for very easy lookups. It also acts as a domain name system, so even websites can basically can provide their IP addresses. They can provide any number of information that is necessary for any identity or DNS system. So it's a very it's a complete system on its own, because it also provides you ways to go through a rigorous process such as auctions and bidding. So ultimately it acts as a system where ultimately you will go through all their process. And also, there are a lot of guard systems there within the system. So it ensures that even though the BCH blockchain is not really doesn't have a like a contract storage concept, it just is itself whenever the transaction is happening. The incentive systems are structured such a way where it ultimately you're assured that whatever domain that you're getting is ultimately owned by you and you alone.
That's great. So that's why it uses CAN, right? It's the name authority for top level domains in normal internet lookups, DNS lookups. Before we get into the technical details, I wanted or the chain specific details, I wanted to ask for the people like me who are skeptical of these name systems, how does this connect with the internet, right? Because you can't depend on DNS, which is a fully centralized, um, name resolution system that depends on authorities. What's the
Yes.
connection? How does it actually get from my browser to a website without going through something like that?
Yeah, sure. So right now you have to rely on these certain authorities. For this name is actually directly inspired from ICANN, which is the authority that allows other people to lease the domains. Having said that, this itself will basically allow us or anybody who's controlling their own domain to be 100% sure that it's owned by them itself, and the storage of that and the lookup everything will happen directly from the node. So there is no separate entity that we have to rely on and fetch the information from. All you need is Electron server, any Electron server. We don't have to rely on like any specific dedicated piece of software. We don't even need any backend using the system. All we need is, let's say, eventually there exists a library for BitCAN, so it can read with the all the contracts that are there in the system, but that's the extent of it.
And
Since
my
it
browser
already
would need
gives,
a. Oh, sorry. Go ahead.
yes, yeah, browser would need at least something so it knows that something like this exists in the first place. But that's the extent of it. Like because after that, it's all completely dependent on the Bitcoin Cash blockchain itself.
Right. Okay. So I think that's important for anybody who's listening to get the concept that this isn't just a toy that exists on the chain. This is really meant to integrate with browsers and have you actually looking up browsers according to this decentralized system. All
That's
right.
right.
So before we get into specific details, I don't know, have you guys looked at the BitCAN protocol contracts, diagrams, any of that stuff? Diagram, Mathieu, Jim?
Yeah, I've had a look at it. First off, I'll just say I really want to compliment like the documentation with it, the transaction shapes, and the documentation in the contracts itself. It's probably the most advanced contract system I've seen on Bitcoin Cash, and it's documented really, really well from that point of view. In terms of some of the other bits, probably where I'm a bit more kind of uncertain is about the leveraging part. So, using Electrum to actually be able to find domains and that kind of thing, actually do a domain lookup. So yeah, I'm keen to hear about that, but yeah, it is brilliantly documented.
Yeah, so I've also taken a look at the contract and provided a little bit of feedback also on CashCrypt specific things. And indeed, it's very well documented and the most complex contract system that's out there, open source for Bitcoin Cash. So that's definitely saying something. I want to also take a moment to speak to the DNS concept more generally. So it's an old ID. At first, it was, I think Satoshi talked about this with a name chain, side chain, which was supposed to do something like this. And then, of course, on Ethereum, it is quite popular, where you see many people using a .eth extension for their usernames. and they also own this then as an asset on Ethereum that's tradable. So a domain you can really own, but also can sell. And then we have seen IDs for this on BCH. So I did a quick search in the developers group. And for example, Chris Passia talked about IDs related to this in 2019. So did Tobias Ruck. And also on the Bitcoin Cash Research Forum, if there's a topic from 2021 about domain systems on Bitcoin Cash. And then also on Smart BCH, there was a project called LNS for Bitcoin Cash domains. So LNS is you can find it at bch.domains, and it was by Mainnet Pat and Kasumi. So this is just to for the context that there's a lot of people who have been thinking about this and who are convinced this is a good idea. And there has also been a lot of exploration about different designs. So I took a quick look at some of this prior work, and they all think in very different directions. And part of this is because the contract system has also evolved over the years. So of course, when Chris Passia was thinking about this in 2019, or when Satoshi was originally thinking about this, it looked very different from how the ideas evolved. So I think it would also be interesting to maybe speak about or compare these different concepts and maybe trade-offs, or this could be something interesting to document later in some kind of research post.
Absolutely. Yeah, the amount of things that are possible and the amount of trust that you can push onto the chain as opposed to having to trust some kind of external sources has changed massively in the last even just 5-6 years. So absolutely the ways you have to approach the problem have multiplied. And I agree. That would be interesting to hear a comparison of those available. So Dagra, just in case you wanted to say something before I move on.
No, I haven't looked very closely. I just thought it was a big diagram.
Okay.
So it's impressively large, I would say.
Yes, and so this is the common, I think, thread here, and the reason that I thought this would be a very interesting one to pick up is that it's quite complex. If you look at the diagram, which I've shared in the Twitter space, if you go to that link that shows BitCANN, you can see the architecture diagram of it, and it's quite complex. And so this is a great entry point for this question of how do you establish trust in these things, like, because as Mathieu, Jim, myself, and Kuldeep yourself as well, right? With Zapit, with your work with Zapit, when you've got your wallet users and they want to interact with some complex smart contract system, and do you facilitate that? Do you block them from doing it until some kind of verification happens? Or how does trust get established? And what are even the issues around it? What does trust even mean when it comes to these kind of contracts? And I know we've all probably thought about this a significant amount. So I was thinking to ask Kuldeep first to explain the Zapit wallet team's past experience with audits, because they've done some audits with their EVM work. And then Dagra, Mathieu, Jim, what kind of issues do you think? What are the issues even? Like, what are the questions to be answered? Not even the answers, about how do we establish trust with these kind of smart contracts, wallets, etc. So Kuldeep, could you go ahead and tell us some about your audit experience and what goes on with that, and what are the outcomes of it, and what do you get and what do you not get from it?
Yeah, sure. So first of all, from the Zapit's point of view, we always go by this approach where we need to know the contracts beforehand. So we know what's in there in form of the bytecode. We don't allow the contracts just to randomly be there. And at least for us, we don't promote it that we trust the system enough, because any contract can take away all the funds from a particular user if that's the worst case scenario, like, and that can happen anytime. So as you said, like, what even is trust? Like, it's very important for even for the wallets and all the applications to know the structure of what it's being dealing with at that time. Just to do this, that's why we went for auditing. So Rapid has P2P contracts on both BCH and EVM blockchains. And since we didn't have any structure to audit the contracts on P2P, I was the guy who self-audited it. But in the EVM space, there are a lot of companies who do this. So we went with a company called Secured App, and there they define a scope of audit itself. So even before the auditing begins, they both parties have to communicate to and fro as to what is the scope of, like, what at what extent do you want it to be tested. So in our case, we already had a system which was pre-audited. So all we had to do is inject our code into that system, because the Diamond proxy contract has already existed for a long time in Ethereum space, and that is already fairly secure. But whenever you introduce another contract to the system, now the entire dynamics changes. They have to make sure that no invalid storage slots are dealt with, or there are no any openings for potential malicious attack to the system. So after this conversation, we went ahead by deciding the scope that only these contracts are meant to be audited, and they need to be secured that anybody else or any other potential party cannot interfere with any other order, because it's a peer-to-peer system. We act just as an arbiter. So in my experience, I saw that it's pretty expensive. Luckily for Indian startups, it's still relatively low, but it's still in the order of tens of thousands of dollars, and it goes even to $100,000 for very complex contracts. So as soon as the auditing begins, they have a certain set of rules, like, because they already have patterns in their contracts. We don't, as of right now. So all we have is like all the contracts are defined independently, and they don't share something within them. But in EVM side, there are a lot of contracts who share the same thing. For example, ERC20 tokens, they have a way how they are designed, but it's not the case in BCH. So they have a list of different ways how something can be exploited in any given system. So first thing they do is they go through all of that. They have like a big list and big known vulnerabilities of how people design their system. As soon as they go through it, they prepare a list of they define it in a way where it's informative, low, medium, high, and critical issues. And then they basically create a proper report of what they think about the system. All they initially ask is what are your expectations and what you are doing. So we have some sort of instruction set from our side as to what is expected out of this project. Now it's completely up to you. You have to audit this completely, and then let us know the report. And it happens to and fro a few times, just in case if they are not able to understand some of the quirks of how the system is designed. But at the end, it depends on the contract system. To be honest, it might take a month, might take much more than that, and that's that. Like after that, that is the end of where we can show that report and establish some form of a trust to our users and to us as well, that this thing has gone through a rigorous process where they have found that the instructions and the data flow is exactly as what we planned or what we expected, and we go on from there.
And can I ask, so when you got that
Yeah.
report on the things that you did, especially the ones that were UTXO based, right? Because the EVM ones are, in both cases, like what confidence did you gain, and then what questions did you still have? Like, I'm not really sure if this is actually safe still. You know what I mean? Which parts were still left open for you when you looked at those results, and which parts did they resolve?
Well, since I was the one who was developing it, from my side, it was already good enough. So, but then it was from their side as like they should be able to figure out if there is any problem. Of course, like if I want something to be audited and it comes out to be 100% fine, and they're like, yeah, yeah, you did incredible job, and there is no flaw at all, I would not trust it, even though I'm the one who made it, because like I don't think that I can make the system flawless in just one go. There has to be a couple of people who can bring in their different perspective. Like if we'll talk about BitCAN, I'll talk about how I have thought about auditing BCS contracts as well, but that can come in later on. But that's the crux of it. Like even I need some concrete explanations from them as to why they think something is failing, or they think that this could be a potential risk. And I would want to engage in a discussion with whoever is auditing, so I can have some sort of a trust as a personal connection as well through them to evaluate their skill level.
Okay, thank you. So I've thought about this topic a lot also, and worked on it as well at a technical level, and then also at a higher just trust, understanding how to present these things to users. And Dagger, Matthew, Jim also have. So before I get into my long list, I was hoping you guys would come up with list of issues, things that you think are important, or things that you've worked on, or issues that you have solved, or things that are open issues that you don't know how to solve. Maybe if you guys could come up with one or two. Dagger, do you have any with Moria and your decks and so forth that are solved or are still unsolved?
I mean, I would like to comment on the question, like, how do you trust what you made actually works? And we don't really have like an audit possibility in BitCANN Cash. There are no companies, and there are very few people in the world that actually are able to do any review. So for all as practical purposes, I would say it's very much like tit for tat. So like I will review your contract and you will review mine at some point. So one way to gain trust is to find the other people that actually are very capable and are smart, and ask them to review your code and go over it with you. Another one to like gain a lot of trust is to write tests for your smart contracts, which is very hard today. The way we solve it is we do it similar like with BitCANN Cash Notes. I'm a developer there as well. We have like extensive reg tests, like test network tests that just spin up a node, and you can execute tests with that node running a fake blockchain. And that's also what we do. We have an extensive test set for Moria, where we spin up a node and then we create all these transactions and try to find the edge cases, make sure like this works, and we also make sure like if you try to do this, that won't work. But it's a lot of work. It would be like, so what's lacking still? It would be a more easy way to test the contracts. And also like
the tooling all around, right? The tooling can definitely improve.
The tooling has improved a lot. The tooling has improved a lot, and I haven't really been updated on what's the latest news. So maybe it's in the works. I don't know. Maybe Matthew can comment on that.
Yeah, so I would love to jump into this topic about the latest test tooling. So I definitely agree that writing tests can give a lot of extra assurances to the both to externally if you open source them, but also just internally, because it makes you think about edge cases and things you haven't tested yet, and to at least get good test coverage. So I think tests are very important. So in CashCrypt, just earlier today, we made a new pre-release. So it's not a full mainline release yet, but you can use it today. And so what we have had for a while now is a mocknet setup. So it's a setup where we use libauth, local transaction evaluation. So there is no real network involved, so no node. So there is no node you communicate to. So not a RegNet node, but also not a chipnet node or a testnet 3 or 4 or whatever. It's all locally evaluated through libauth in a JavaScript VM emulating the BCH virtual machine. And so first, that was only available for simple contracts. And with simple contracts, I mean using the simple transaction builder. So only one contract, no complex contract interactions, and also no different instances of the same contract. So they all had to be on exactly the same smart contract address. And now we have opened this up to our new transaction builder, which is just a much better API. So it works with adding inputs, and each input has an unlocker. So because this is a more generalized way to build transactions for UTXO blockchains, then you can combine any number of different smart contracts. So instances of the same contract, but with different parameters, but also totally different contracts. So for example, for BitCANN, this would be relevant. And actually, Kiok is the person who started this work with his PR, and then Roscoe and I continued polishing it. So we merged this as an initial version. And so what you can do is you initialize a mock network provider. So then you have a mock network environment. And you just add fake UTXOs. So you create UTXOs to specific addresses you want to test. And then you can start writing transactions. And this transaction takes into account all the local context, so which UTXOs exist, but then also things like the lock time, the block height you set in this mock network environment. And if it fails, if your contract, because you can also test for failure cases, of course, so you might want to explicitly make it fail by passing in a wrong parameter or something that is out of bounds. And then you will get, because of CashCrypt, you will get a two-way mapping. So you will get a nice error that's thrown at which line your contract fails, which input this is failing, because of course you can have many contracts in your inputs in a UTXO transaction. So it will say, for example, input 1 failed at line 11 in CashCrypt, and then it will give you the provided string. So CashCrypt has the option to give a human readable error message for each require message. And then it will throw that error, so you can write your require checks. So like you would do with Jest or with Vitest, with any JavaScript testing framework, you can do expect fail require with, and then this message. And this way you can have a really elaborate testing framework. And this was in part inspired by the work done by General Protocols, because as Roscoe told me, General Protocols has an extensive custom-built testing framework for any hedge, but this didn't generalize well to other contracts and is more low-level using libauth. But now we were able to generalize this in CashCrypt, and at a level that it integrates very well with the rest of CashCrypt. So I think this part of the tooling has improved a lot over the last year. And by Bliss, we will have an official release with the version 0.11 release for CashCrypt, that this is all stable and widely usable. So yeah, that's for the testing. And then I think there were also valid points about how do you even do contract audits on Bitcoin Cash, because there are no firms that specialize in this. So first of all, this might become an opportunity for someone in the future to actually create such a company or such a service to offer smart contract audits. And I definitely agree with Dagger that if you have some people in mind that you would like to take a look at your contract, just sometimes asking them nicely or trying to nerd snipe them often works. But also if you have a budget, I'm sure people can be convinced by making some more free time in their weekends, evenings, for example, available, if you actually have a budget for smart contract audits. And even wider than just Bitcoin Cash, there is UTXO expertise not only in the BCH context, but on BTC, or on BSV, or even maybe on Cardano. There is just people who have a lot of knowledge about UTXO smart contracts, and who would, with a little bit of extra work, be able to figure out most of the relevant differences for Bitcoin Cash. Because I think a proper audit, it's not just taking a look at the CashCrypt code, because that's probably what we would do with Tit for Tat, that people take a look at the CashCrypt code, or maybe even at the protocol design, but they won't write up a full 10-page document discussing all the possible edge cases. And this is what you would get if you have a budget of tens of thousands of dollars, of course. You expect a document, you expect back and forth. You expect something detailed and with a lot of analysis. Whereas if it's more on this voluntary basis from goodwill, then it's of course more limited, which I think is normal, but it's something to take into consideration. So if you're launching a high value thing and there is budget for such contracts, then it could definitely be worth considering going through the effort to finding someone who is capable and willing to make all this time available for a deep audit and writing a whole document. And usually this is then also made public, so you can say, oh, this is what the audit found, and we addressed this in these cases, and this case was only a low security issue, and we didn't want to do a whole overhaul or something to fix it, or the design is such that now we don't think it is an issue. And then at least because the audit is open and public available, and then the changes are also publicly communicated, and as a user you can have an idea, all right, it's not just the team which says that it's secure and not only their reputation. You can pretty much add the reputation of the original team plus the reputation of the auditor. So this should increase the trust by users in this code. And one more point is the audit. I think audits usually only cover what is the intention. So if you have a protocol and the intention is for it to have a certain behavior, then I assume the audit will mainly check whether the smart contract code does what the intention is, right? And whether there is no gaps where they can be exploits. But sometimes with these economic protocols, even the intention itself is questionable. So for example, I think here also there was some economic security regarding the DNS system. But for example, this economic security is another aspect that's not technical and not only coding, that might also be put into question. Or with some of the financial protocols, there is certain incentives or game theory. So I think that would be, in my mind at least, a separate part of the audit, where it's not just a code audit, but this would be someone who is thinking about the wider economic context and security context of blockchains.
I actually was having a talk with a company called Halborn. They're like a boutique crypto auditing and security company. And one of the parts of their slides was this point, which is not only looking at potential technical vulnerabilities, but incentive vulnerabilities, just like you were saying. I think they call them financial or incentive vulnerabilities. Yeah, but it's definitely a known thing among the experts who do this stuff, which is great, and it's something that I'd like to make available in the BCH ecosystem. And I also hit the heart emoji about 100 times while you were talking, because that development of the testing frameworks and tooling is so incredibly important and valuable. And of course, I wish we had it all. But as you said, we had to come up with something custom. And I'm so glad that it's being generalized and it's available to us and to everybody now. I'm really looking forward to using that on the next thing we work on. Dagger, I think you were about to say something.
Yeah, sure. Like just more stuff to gain trust. One would be to actually have your contract open source, because having it open source means that you trusted yourself. You're not relying on security by obscurity. And also time. Just the longer the contract is on chain, the more money is in it. The bigger honeypot it becomes, right? If there's money available and it's hackable, and then it would be at some point probably. So just give it time would also increase trust. I think it's this point we can be sure that like the Cauldron contract works fine. It has been running for more than a year and has had some significant money in it. And finally, I would like to say, when like developing contracts, I would say like resist the temptation to add more features than necessary in the beginning, because that makes it more complex and adds more attack vectors. So yeah.
Yeah, to jump in there.
Absolutely.
Especially for Cauldron, I think even more so than the total value locked, because even on Ethereum, you see sometimes very high value protocols even being exploited after some time, because you often have a dedicated attacker who does even more work than the research firm and the audit firms. But this is only at high complexity. So the big advantage of Cauldron is that the design is very simple, contained to one contract, and then even it fitted within the current very low VM limit. So the complexity is constrained a lot, and which is of course a big advantage when it comes to auditability. So indeed, with these more complex systems like BitCANN, sometimes it is just necessary to make your protocol complete, or all the features you want to deliver to users. But the big cost indeed is complexity. And complexity, I would say it's not a linear, right? It's not if you double the amount of code, you have only double the complexity. No, it's probably more like an exponential, where if your contract is small, or like only half the size, and you can cut a feature and it's only half the size, then you cut the complexity with more than half. So you make it much easier to audit, and also you can be much more certain that there's less space for vulnerabilities, because there is simply less area to cover in the review, less area overall, and then also less area after you made the change. So so definitely agree
Yes.
with Dagger's point.
Definitely about complexity. I have a long further list of points. Jim, did you want to say? Did you have any thoughts on this question of like the open-ended questions, or things that you think are solved, or etc.?
Yeah. So I don't think much is really solved. Like I see this problem in open source generally. We still have pieces of software that are basically military grade, and we're finding vulnerabilities even in those. I think with Bitcoin Cash, I know we've kind of discussed this internally. There's a few common gotchas, and I think even just putting that list out there, explaining them, I think that would go a long way towards helping. Just things like making sure that you're not storing, you're not trying to pay out to a non-standard blocking bytecode, for example. Just those kind of simple things. Like I bumped into those in contracts. The other thing that might eventually become possible is kind of getting a decent feedback from a large language model. I actually reckon in the future that might be a possibility, where you can kind of feed it a diagram of how the contracts are meant to interact, feed it the actual scripts or cache scripts itself, and actually, have that do a partial audit as well, which isn't necessarily perfect or great, but it does give like a indicator towards a particular, like whether a particular contract is safe. So I think there are probably some exciting avenues going forward, but we're not there yet. Definitely not there yet.
Right.
And one thing this also reminded me of is the security of the tooling you're using. So, for example, on EVM, the famous DAO hack, I was learning more about it recently. And the famous DAO hack on Ethereum, which eventually got rolled back, was because of a re-entrancy bug. So in Solidity, the default behavior of a function is that it can be re-entered. So this is kind of like a recursive behavior that can be called on your function, and that has a hidden default behavior. So it also matters whether the smart contract language, the high-level language you are using, has these kind of abstractions and hidden behaviors. And I want to say that the benefit of CashCrypt, I would say, is that there's very little, and also just because there is not a lot of opportunity also for hidden behavior and side effects, which open up potential for exploit. So the surface area, even of the smart contract language itself, I would say is smaller. There is a few small points where we can improve, and I know that Dagger has run into one of them. So, for example, one thing is with CashCrypt, you can say as a function argument, I expect the user to give a 20 bytes size unlocking argument. But then it seemed for the developer that this was validated somehow. But currently, this type is just a type that you provide. So you kind of assert this will be 20 bytes, but you need to actually do the length check currently in your contract code. So this, I would say, is a shortcoming of CashCrypt, because it gives the developer a certain ID, namely this item is 20 bytes, whereas in reality it might not be 20 bytes. So this can be a cause of confusion. And as Jim said, if you expect something to be 20 bytes and you use it as a locking script, or you construct a pay-to-public key hash locking script from this, and it's not 20 bytes, it's actually 21, then this messes up the whole thing. And currently with the standard list rules for outputs, you have an unspendable contract. So yeah, this is currently the one gotcha that is on my mind related to this. But my main point is that there is much less hidden behavior and side effects than there is in Solidity. And Solidity is actually notorious. So even other contracting languages on EVM, like Viper, they kind of criticize Solidity for making it hard to write safe contracts. So I think the contract language itself is also needs to be designed in a way so there is as little surface area for these common mistakes as possible.
I want to expand that point, actually, and this was one of the points I made during the presentation at BCH Bliss last year, was that there's not just the contract. You can't just look at the contract, because fundamentally people put money into this contract, and you, with no other kind of guardrails around the contract, you in the general case, you cannot guarantee that just because you put money into it that it's safe, regardless of how safe the protocol is and the contract itself is. And so there's an additional layer outside of the contract that is necessary, not optional at all. The tooling, the compiler is somewhat optional, but it still fits into this umbrella of there's things around the contracts themselves, the tooling, the libraries, the apps, and so forth. And especially those things that interact directly with the contract and making transactions, like you said, they have to be very solidly audited and safe as well. Because however amazing your contract is, if you put some garbage into it, you can lock up funds, right? Or you can cause some kind of very bad behavior in the contract, which may impact only you, or it may impact others if the contract isn't made to handle it well. So yeah, there's additional layers outside, which adds to the cost and concern about safety, right? You have to make sure that the library is audited, that the way it gets used is correct. When you're working with an app, you go to a site to use some kind of protocol that you trust. How do you also know that they're using safe tooling to help you interact with that contract and so forth? It's a difficult thing to it's an impossible thing to be 100% sure about safety and security, right? That's a famous it's just impossible, but it's worth it for us to wrestle with these and come up with the best solutions we can.
There are some user gotchas though. For example, a contract has like a Bitcoin Cash address. So some people have asked, like, with Moria, do I just send money to this address and get a loan? And if you do that, you would literally burn your money. So perhaps user presentation of contracts, like in a Block Explorer, could be improved to not show a Bitcoin Cash address that you can send money to.
I want to also emphasize this point because it came up in the last space of that we did together when talking about this pay-to-script proposal and how it related to contract safety. So one feature actually is that this pay-to-script, because it is a raw script and it can be any length, you cannot easily generalize this to an address format. And the chip also explicitly says, well, the goal is not to have this as a user readable address format, because the goal is not to send money directly to this contract. There is a UTXO that lives on this contract where you can interact with, like with Moria, but it's not the case that you can just send money to the contract and expect things to happen. So I agree that not having an address where users can just send money to and expect something to happen is a feature actually. And also I hope that this ignite some discussion also about this pay-to-script chip, because I think that's one of its very promising features.
Right, and then yeah, not only that is your money going to work, but it may just be blocked forever if you send the wrong amount or some random UTXO to a contract. I mean, nobody told you to do that for sure, but if you just do that, you may just lose your money forever if you send it to that, right? Just without knowing what you were doing or participating in the protocol. And yeah, and that's, yeah, like you said, that's part of this thing of the contract alone can't make the money safe. It's the contract and the tooling and the interaction with it. It's one package.
Maybe you can have like a small introduction of pay to script, because I haven't read the proposal.
Oh yeah, we'd love to. So the pay to script chip, it bundles a few things, but the main thing is that you can pay to a script output. So currently we have pay to script hash, two variants, and pay to public key hash. But pay to script would just make the currently non-standard script outputs, and would make them standard. So currently you can send to a weird locking script, but only if you have minor assistance. Minor assistance to help process your transaction. And this would just make them also standard, which means that new IDs like zero JSON's IDs around zero confirmation escrows can be implemented directly in script, which helps the contract, but also it helps many contracts, because not only does it removes this address, which is one thing that can be a drawback. It also removes the hash, so you always add like 20 or 25 bytes overhead where you might not need it, and you obscure the contract parameters. So if I want to have a UTXO where everyone can clearly see what the full script is and what my parameters are, so they can interact with the contract, and so it's easily findable, then right now I have to hash it. There is no opt-out. So I hash my contract. Well, now the parameters are no longer visible. So I have to put them in some kind of op return. So I still add all this data on chain. And the eventual script also has this data. So there is actually duplication of data. Then there is this extra hash. So there's just a lot of overhead going on that is nice, because it gives you an address, and it gives you some privacy. But for many applications, you don't want an address for your script, and you don't actually want this obscurity or this extra privacy where you hash your script. So that's the main idea behind the pay to script chip, is to make things that are non-standard standard. So currently, if your friend is a miner, you can already use it. So an attacker can exploit this. So the worst case doesn't change at all. It's just the case for us normal developers who don't have miner friends, or who want to work within standardness. Then we can also use these features, and we are no longer restricted to only using pay to script hash, where we hash our script and have this privacy. We also have the option of using raw script. But one important consideration is that this would still use the 201 opcode limit. So the VM limits would be different when using raw script, because there's different considerations. And now the sender actually interacts with this whole output. So the whole output script is included in the transaction, which is a little different. So I just wanted to mention that the VM limits are different.
It would be a great... I don't want to have a strong opinion about it yet, because I haven't reviewed it carefully, but it does seem to fit in the just general bare metal approach of BCH, where you make things possible and people use it as makes sense for them, as long as it doesn't interfere with the scalability, speed, and money use case, right?
Yeah, and then for completion, because I said there were a few things that the chip changes. So the main thing why it got its name was pay to script, but then it also updates the maximum length for the NFT commitment, which currently is 40 bytes. But we don't want it to ossify at 40 bytes, I think. Jason has also said it. So it was just taken as 40 bytes. So it was super, super conservative when the cash tokens chip introduced a few things at once. But now, after cash tokens has been active and people are more comfortable, and it's clear that increasing this length would only allow for more flexibility for contract authors. So currently 40 bytes only allows for two pieces of state of 20 bytes. And the proposal suggests to increase this up to 128 bytes. So I would really like that, because you can just keep more state, more information in your contract, in your NFT commitment. And then one other thing it changes is that now with the VM limits, we kind of retarget the limits. So we make sure that the worst case doesn't get worse. So we don't really increase the compute available to contracts. We just say the worst case that's allowed right now, well, we open this up to everyone. But the pay-to-script chip, it also suggests increasing. So currently there is an input limit length of 1,650, if I remember correctly. So per contract input is the limit, and it would remove this input length limit of 1,650, and then it would be 10,000. So it would increase the maximum contract length. I think this is roughly 8 times, and this would be an absolute increasement, but it's not bundled with the VM limits because that wanted to be super conservative, just to retarget all these parameters and introduce kind of a framework. But then this last item in the pay-to-script chip, it suggests that we also just bump this number up to make sure that people can implement advanced smart contracts without having to run into limits. So that kind of covers the full scope of the chip. But the name and the key idea was mainly pay-to-script. But then it also covers these other numbers.
That was the most amazing introduction I've heard, for sure. Very nice. Yeah, and it sounds like an appropriate thing, but again, I need to review it carefully myself. And GP will also review it to see how it goes. So I wanted to go on to another one of these issues. I wanted to throw my issue into the ring, and this one is you try to make things safe, and you try to audit and check and be careful with everything, but you're writing code, and code has bugs, whether intentional, not intentional. I mean, whether they're things that you would call a bug, or there's just like a ambiguous behavior that might be considered a bug or not. So code has bugs, and with these UTXO contracts, as they have been written so far, you can't just update them, right? And I have seen in EVM, there's sometimes update keys, which can also be used to rug a contract by completely changing the underlying code and so forth. But have you guys thought about this? You've written a protocol and then you find a problem with it. And have you seen any kind of, or have you come up with any kind of solutions for, okay, we still want to keep this going, but we want to migrate to something that works? Have you seen anything like that yet on the UTXO contract?
I mean, the only thing...
Yeah, I would like to...
Oh, sorry.
Okay, I'll go. I've been waiting for a while anyways. So I've been working on this concept, similar concept that you were talking about, Imogen, just now. That whenever you find some sort of a problem in one of the contracts, it's impossible to change that particular contract itself. So although there is no known way to fix it right away, but I've been working side by side on a DAO system where you can have a voting system. You can delegate your votes. You can have your own DAO. And then that DAO is responsible for upgrading the contracts. So for example, BitCANN right now, that can inject itself into that DAO. And that DAO can be anything. Let's say Moria itself creates a DAO for the token holders. And now what happens is that the stakeholders will have a minimum limit. Something like this also happens in Uniswap and other contracts, projects that rely on DAO mechanism. What happens is you submit proposals either to introduce new functionalities or remove or replace new functionalities. And then there's a voting period that happens for that particular proposal. And as soon as that proposal ends, let's say they add a limit of 2 weeks or 1 month or whatever, then anybody can execute that particular change to the pre-existing system. So that can be one way where if there is something that still fails in a system that was originally created, this proposal system and this DAO system can act as a way where you can basically, in quotes, remove the contracts that were responsible for, let's say, BitCAN goes a DAO approach, and you can introduce new contracts that have fixed that problem itself.
So, but how would that work technically, right? Because, for example, you've got the BitCAN and you've got all your operating tokens on this contract, on this address. Mm-hmm. And now the DAO says, okay, we've decided we're going to fix this bug and migrate to this other contract. But it's not like that just happens automatically, right? Your UTXOs are still sitting on this other contract. So the contract has to support the DAO mechanism of, well, whatever the rules were, those don't matter anymore. We're going to move everything on this address or whatever, according to some rules, to somewhere else. Is that how it works?
So since this approach, this base pattern of BitCAN is basically most of the all of the authorized contracts live inside immutable NFTs. And whenever you're executing something using the main controller or registry contract, that's when you're attaching the UTXO of the registry itself and that authorized contract's UTXO. So now, so basically that authorization UTXOs live within the controller itself. So from the DAO's perspective, what will happen is, of course, this controller needs to have a function or sort of an entry point where it allows itself to be called from a contract that is a DAO control contract. So what happens is that DAO gets the access to manipulate the NFTs that exist in the controller contract. So you can outright burn the NFTs that actually were acting as a thread NFT for all the other contracts in the system, and you can introduce new thread NFT because apparently that DAO can have a minting NFT that controls everything on the BitCAN or any other project system.
Does that mean that every execution of every step in that contract must consume and reproduce the DAO controller?
No.
Only
the updates. It's only dependent on the proposals. So the entire system will keep on working as it is. It has got nothing to do with DAO. But whenever we have to do anything with proposals, so there are three functions that almost all DAOs have. So adding, removing, and replacing the existing functionalities. If something like this were to happen, so only when the DAO's proposal is passed, that's when that functionality takes into action. And even at that time, it's just like a it's an instant thing, because immediately the UTXOs are burned and new UTXOs are created, and the function and the contract still continues existing. Like so any of the BitCAN holders or anybody else will never ever be able to tell from the outside, or even when using the application, that this system was just updated.
I cannot conceptualize how that works with UTXO. Is that explained in the BitCAN, or is it in your DAO documentation?
It's in my DAO documentation. I'll release it next week. Yeah.
So, okay, I'm gonna assume that there's somebody else out there who has similar questions to me. So I'm gonna ask one more time to see if I can get a little more understanding. Let's say I have one of the NFTs in BitCAN, and it's sitting on the shared address, right?
Right.
And then the DAO says, hey, there was a bug. We need to fix the behavior of how auctions work.
Right.
But my NFT is still on the original code, right? It's still, because the address represents the code, unless we move to P2S perhaps. But the address that it's on right now represents the code. So that can't automatically just magically change. How does the actual underlying code change for my existing domain?
Okay, what do you mean by your NFT? Is it like your domain, like emergent.bch, or the contracts NFTs, like BitCAN's NFTs?
Yes. I don't know.
Okay.
But so, I think you get the point, right? I'm saying that the whatever NFTs there are on specific addresses which represent specific code, and whatever some other things say doesn't have anything to do with what is actually locking those NFTs. And so what's that missing step where the code that governs these NFTs changes? Like, how does that actually change when the DAO decides something?
Okay. So in the main contract, the BitCAN contract, they have different NFTs that have different responsibilities. But all the other NFTs that exist outside of the system, they are just to prove the ownership. Like they don't have any influence on the BitCAN system. But whatever exists in the BitCAN system, all the NFTs exist only with the registry or / controller. So in reality, all the other contracts, all the 9 other contracts, auction bidding, or all the other, they only exist as interfaces. And the real executions happen with only the controller register. When the zero, okay, I'll just give a little bit technical and then I guess it will make sense. So zeroth input acts as the authorized thread NFT, which is being used by the controller itself. And that is the only restriction that it has within the system, where it says, I will execute this code if this particular NFT or any of the authorized NFT, which has 35 length and it has locking byte code, is used from myself and sent to myself in the zeroth input. Now it doesn't care what that content is. It's because initially, let's say whenever the system was designed, the creator would have sent those NFTs in the first place to create those threads, which means they are already sending the pre-authorized NFTs to the registry. So now what DAO is doing is it's just replicating the behavior of what happened in the Genesis when BitCAN was created. So just those existence of those NFTs or creating new NFTs as in new threads is enough for the registry to understand that now I have this more scope of executing more code basically. So you can outright remove the previous auction contracts because like removing as in like just the NFT that exists in the registry, like the contract will still exist. But the auction contract doesn't have anything, like it doesn't have any NFT related to BitCAN. It just have random dust. But still, in order to unlock that dust, the code of the auction contract must be executed within the transaction. So the entire transaction or registry exploits this exact need for something to be unlocked so it can execute. So the DAO will add new NFTs, and those new NFTs will now, of course, represent a new contract. And the proposal, since it can be replaced, so what happens is the NFT that exists inside the BitCAN, that will be burned and new NFT will be created instantly within the same transaction. And now the new auction, it starts to point at the new auction contract. I don't know if it makes sense.
Yeah, that makes more sense. So there's a core set of key contracts that get migrated all at once or in some steps. But anyway, that get migrated, and then all of the extant domains and so forth, NFTs that are out in the world, they don't have anything. They don't care about exactly what code they're running on. They run on whatever code the DAO has authorized, which is the central pieces. Okay. Have you guys seen this? I've never seen that before on UTXO. This is isn't this the first time somebody has done this on UTXO?
Yeah, the whole BitCAN thing's actually kind of blowing my mind. Like it's incredibly impressive. And no, I've never seen anything like this yet.
Well, this is a good place to jump in with what general computation kind of enables, because we of course our goal is to make it easy for people to develop things, and they will come up with great things like Kiyoki is doing here, but we don't know in advance what things people will come up with, right? And I mentioned this in this general way because some of the chips we are currently discussing are also about general capabilities. And so one thing in the BitCAN system that's a very nice illustration of this is that these names that are issued, they are checked that it only contains certain UTF-8 characters, right? So, for example, you can not have numbers in your name. I'm not sure if that's enforced, but you cannot have all the existing characters in your name. So currently, if you take a look at the diagram, there is actually a contract that's enforcing these names. So it enforces that these names, and a name, of course, is just a series of strings, that each of these letters in the string is in the allowed set of numbers and letters, right? Or mainly letters, I assume. So that this name, this whole string, is allowed. So what you would do normally for this is you would have some kind of looping construct, right? That checks each element, each UTF-8 byte in this string all conforms to this specification of allowed characters. But as you all know, there is no construct of loops inside the VM. So this actually, and I talked to Georg about this, it adds a lot of complexity for him to figure out, oh, how can I enforce names without loops? But loops is such a general construct that can be used for pretty much anything, but it can also be used to enforce which characters can be in a string. So I guess my kind of point is that this complexity is that we talked about before, that you want to minimize. It's not only always at the tooling layer, but as general protocols, as also extensively talked about in their blog, it's also at the consensus layer. So what does actually Bitcoin Cash script allow? So before native introspection, there was a lot of extra complexity required, not for the logic itself, but just to make it, to express this logic to the VM. And the same, I think, is the case with enforcing only specific characters can be in a string, because there is no looping construct currently in the VM, so there have to be complex workarounds. So I guess this is also one use case where we can say more computational abilities for the VM would solve a lot of the engineering hassle or overhead that now contract authors have to invent new solutions for.
Yeah, and longer commitments, NFT commitments.
Yeah, what we talked about.
That.
Yeah, for the the pay to script chip, this is one use case that would also benefit. So I think it really shows that the most advanced use cases, which are pushing the kind of boundaries of what's possible, they are the ones that run into the limits, right? They run into the limits of the NFT commitments. They run into the limits like Moria with the currently the VM limits. They run into not having loops. So it's always the people pushing the boundaries and researching what is the most advanced system I can build on Bitcoin Cash that will notice what is not possible yet. So yeah, that's just a small point to emphasize that it's great that Georg is pushing the boundaries, and it also shows where Bitcoin Cash could improve in the future.
I remember back in, I think it was 2018, I cannot remember what platform or where it was, but we were having a discussion about covenants, and you know what you just said about how, okay, now you've got this compute power that you can do general computing with, and what that means is so enormous, right? It really is enormous. And the smallest ideas that we had, right, at the time, that was when AnyHedge was conceived by Imaginary Username. And if you look at the complexity of AnyHedge, I mean, it took us a lot of work because there was no tooling and there was no safety and there was no nothing. We had to figure it all out ourselves. But fundamentally, it's very simple, right? Like what it does is very simple. And what Kuldeep is doing here with BitCANN and the DAO that he talked about is orders of magnitude, maybe 2 orders of magnitude more complex than what we did. So while the attack surface and security becomes a much bigger issue, also the tooling is improving along the way with it. But the point I made back then was that there's literally diamonds just strewn about the floor in terms of what kind of business ideas and entrepreneurial ideas are possible and what kind of businesses and services could be built. They're just all over the place, diamonds all over the floor. It's like the early days of the internet. Yes, there's going to be some scams and bullshit, but there's also a huge amount of opportunity because, like you said, there's general compute available for your money now. What you can do with that is absolutely enormous, right? You can't imagine all the things that are going to be done with money as they start to disrupt legacy systems and replace trust in a lot of places. So yeah, and this is a call to entrepreneurs and builders. There's diamonds everywhere. Come pick them up, or else Codeep will take all of them and Zapit will take over the world. So come get your part.
I'd like to just say one more thing.
Yeah, go ahead.
Okay.
Boss.
So, along with that, like, first of all, I just want to mention, like, I want to request that this base architecture is, in my opinion, it's so powerful that you can have hundreds of contracts talking to each other. And this is just like the subset of what is possible. BitCAN is just representing just one category and commitment level of restriction to how it can scale. But what I can imagine is like this can be a very big system. Like it can be like 20, 30, or 100 contracts interacting with each other and everything working flawlessly. Along with
Explain more about
oh,
what you mean by bigger. I think this is going to be exciting, but maybe people don't grasp what you mean by bigger. Like what do you mean?
okay. So since
Not
this
just like the number of contracts, but what can you do with a bigger thing?
I like the system can be very complex. Like it can be very big. For example, BitCAN itself is pretty big as compared to any of the single or two contract system. Right? Just like this, there can be a lot of things where, for example, I'll just go by BitCAN itself. That is a pretty decent example. So in BitCAN, if you'll see domain.cache, that has an entry point, which is like a function where you can plug in other contracts. So you can since domain.cache has each domain.cache has three NFTs. So one internal, external, and like one NFT that is owned by the owner, and that lives anywhere. But internally, it has two NFTs, internal and external auth. So internal auth NFT along with the domain ownership NFT can be transferred together to any other system. So imagine this, that I am creating a leasing contract. But of course, like if I have to lease something, I should prove that I am the owner. So they can inject in the transaction, they can inject the internal auth NFT of the domain.cache. They can, and then they'll attach their own ownership NFT with it within the transaction, and then send that fund to a leasing contract. So their NFT will go to a leasing contract, which will basically prove that this person was the owner of the NFT, and the leasing contract will start. So I can buy right now hundreds of domains and then start to lease out them and create a separate revenue source for me. The same way, I can attach another contract system, which can very well be just like this, which is for loaning. So I can borrow against my domain. And now imagine that BitCAN itself is so right now registry.cache is not upgradable in itself, but the upgrade contract looks a bit different. Imagine it was. Then you can have this another DAO system on the left, as I'm imagining. So the DAO, which has like 10, 12 contracts, it's talking to BitCAN, which has 10 contracts. And there are hundreds and thousands of domain.cache contracts, which are independent, controlled by each owner. And then each of that individual domain.cache contract can interact with hundreds of other systems where two of them are like leasing and loaning and borrowing or whatnot. So collectively, it's like so many contracts that are independently working, all on UTXO. So it doesn't rely on any storage on anything. It just is.
That's beautiful. And a lot of that is is, like Mathieu was saying, enabled by the recent upgrades, cash tokens
Yes.
especially. But of course, the VM limits also opens up the window of what kind of computing power you have available to do all these things. Okay, you explained that very well. That's very cool. Just remember, kids, before you put your very valuable domain into one of these things, make sure you trust it, because you don't want it to get locked up in some bad contract. Along the lines of this discussion. That's fantastic. Actually, that point, that specific one you brought up, is a great one, because as Uname pointed out many years ago, there is some amount of absurdity to getting loans for one liquid thing based on another liquid thing. That's usually not how loans work, right? But in this case, this is a good example of how loans typically work, which is you have this illiquid, non-fungible thing, and in this case, a domain, and it's valuable. You know, it's like property, it's a house, or it's a domain, or something like that. And you want to get money based on that, and you put it up for collateral. That's a more standard loan that makes sense and starts to integrate more with commerce. And I think these examples of, for example, domains going up as collateral for loans and so forth will be a really foundational, because once that happens, and as Dagger was saying, the Lindy effect of things working over time and people actually using them and trusting them, because then that starts to edge into other areas such as physical world property, real estate, and so forth. There's going to be some gray zones where legal systems and the blockchain start to interact. So yeah, I'm looking forward to these types of interactions between assets and contracts and rules, and it's a new place. There's diamonds everywhere.
Yeah, I've been super excited because of this. It's there's so many things that can happen with the Bitcoin script. Fundamentally is so powerful. I sometimes feel that this is probably how you all felt in 2011, 2012, 2013. I wasn't there to witness Bitcoin, but I feel some sort of an excitement because of all this that that doesn't let me sleep sometimes, because I'm so excited about this that I'll rather just work and not sleep.
There's too much potential.
I love it.
Okay,
That's
I had a few other points. Yeah, right?
Yeah, so one thing I did want to add is because I started off giving a bit of context with how IDs for domain name systems evolved and which people talked about it and so forth. And then also that it's on the research forum. So one thing, because of course you put a lot of work in the README and having diagrams, but it's nice if people have questions and that there can be a back and forth. So I would encourage you to, when you have the time, to also on the Bitcoin Cash research forum to open maybe a topic specifically for BitCANN, but then also maybe to on one of these older posts, you could also just add maybe just give it a read and then add what you think the people discussing this earlier got right and how you think about it. So that can give like a maybe a good idea for people who have talked about this for a longer time to kind of catch up to where you are. And then any questions or remarks, then we can put it on the research forum. So that could be a nice way to collaborate, because it is a very complex system and ID. So.
Yeah, sure thing.
Yeah, I agree. I had one more point I was going to add, but before that, Jim, Dagger, did you guys have additional, right? Because we're kind of running through a list here of, what is trust? How do you establish trust? Where does it come from? Like, how do you communicate it, etc.? Did you guys have any other points that have come up while you're listening here?
None really from me at the moment. No, I'm actually just kind of working through the BitCANN contract as it's being discussed, and no questions for me at the minute.
The man is cooking. He's gonna find you a critical. A critical vulnerability, Kuldeep.
Yes. Finally.
Well, in if you don't have a DAO, then you have to, like we were talking about, like transitioning contracts, and you need to encode some way of ending the contract. Like for in Moria, we knew beforehand that it was a test run, so we encoded a sunset clause that makes it more easy to just end the system and the protocol. But I would prefer DAOs. I think everyone should make a DAO and then come trade them on trade the tokens on Cauldron. So I prefer that.
And in some cases, it might make sense not to have a DAO, right? If you want to have absolute certainty that the rules are not going to change on some contract or something like that. There's also a case for where you wouldn't want it. So it's another one of those beauties of a bare metal chain where the rules are up to what you build and what you want, whether that's privacy or absolute strict rules on the contract or the ability to upgrade or whatever it is. So I had one last point on the question of, that everyone has brought up, that it's very hard to find people to review these things. Traditionally, it's very expensive to do these things, and it probably is smart to get outside eyes as well as friendly eyes on things. And so there are companies that do reviews for these things and audits, as Kuldeep pointed out, and I have talked to. And who does it make sense for to pay for these things? So the obvious answer is, the contract maker pays for it and then presents it. But Ramit's in the audience there, and Kuldeep, you guys at Zampit, so far I think all the contracts you have worked with are ones that you made yourself. But let's say somebody else makes a complex contract system. And they're like, hey, you should really make this available in the Zampit wallet. Would such an audit report convince you? Or would you want to be part of the audit process? Like some kind of collaborative audit process with a third party or some kind of organized process? Have you thought about that? Who pays for it? Who is involved in these processes? And what would it take to convince you to make your users' funds subject to the rules of some contract system? What level are you going to require for that? And we face this too, right, at General Protocols, because we're ranking the XO stack and XO wallet. So we're thinking about these issues of how do you establish that trust in somebody else's system?
I think from a business point of view, it would be very hard to involve ourselves into an audit structure, because then we would have to give up resources, man hours to actually do that. So there has to be some sort of a balance, like how from the ROI perspective, how much are we getting in return from a profit making business? From I think directly relying on audit, especially from some reliable source, will probably the end of it. From maybe there can be like another session of review from us when we are about to finalize, just like we do it with packages when we have to introduce something in our internal backend servers. That would be my opinion.
Nice. Yep. Matthew, I wanted to ask a specific question to Jim, but Matthew, Dagger, did you guys have anything on this idea of, who pays? How do you get convinced of someone else's system when you have to put your reputation on the line?
I mean,
Yes.
An audit is basically someone taking responsibility, it's like a lawyer signing off that this contract is good, right? So
yeah, but if you have a wallet, you're still putting yours, right? You're transmitting that responsibility. You're delegating your reputation to that audit firm, right? If they're wrong, you're also wrong.
No, not really. I don't agree.
Maybe I can speak to this as a wallet. Maybe I can speak to this as a wallet developer. So what I think, at least how I treat it, is with Wallets Connect, you kind of say, oh, this is a general protocol. A general protocol, so not general protocols, but a general way to communicate with a wallet and a dApp, and you can use it for anything. So of course you cannot audit, or the wallet developer has no say over what this is used for. So this enables a whole ecosystem of wild experimentation. But I think if you build functionality inside your wallet, then you are kind of responsible. So if you have a swap feature, let's say the Bitcoin.com wallet has a swap feature where you can, with a traditional on-ramp, you can buy Bitcoin Cash with fiat. And then you see there's also a swap mechanism built in with Uniswap. But then you use the Uniswap feature and you lose all your money. Well, there is the responsibility in my mind is the same whether you use the built-in onboarding feature with an exchange or you use the built-in DeFi protocol. So it's kind of when a wallet has something built in, then it kind of gives the guarantee, or at least the brand recognition from this is under our umbrella. This is kind of what we take ownership of. So I think there is a very different, a very important difference between like a protocol which can connect to anything. So it's a bit of the Wild West, but also enables a lot of experimentation, and a feature that has custom UI directly from the wallet. There you have a much higher bar for quality and also for review. So I think it would be reasonable not just to take on face value, oh, it has an audit from somewhere, let me implement it with a specific UI in my wallet. I think you do want to make very sure, where does this audit come from? What is the reputation of the audit firm? Can there be 2 audits? Do we want to double check all the code? Do we want to write additional tests and so forth? So I do think it's not very straightforward to just integrate something in your wallet and say, I'm not responsible because it's an external protocol.
Yeah, and I think there's going to be some gray or possibly even black and white divisions here of, these are things that we have tested ourselves and that we validate or verify. And then there's these other things that, as a wallet user, you can interact with them, but you're going to know very clearly that you're out in the wild, wild west, so to speak. You're out there. So there's probably going to be some amount of that, or at least we are planning for something like that with XO. Is that the same kind of idea you mean, Mathieu?
Yeah, I think so.
Okay. And Jim, would it be possible to ask you for a quick explanation of the templating systems and what that means, right? Because that would fit in with this whole audit concept and the idea of checking something for safety and what is the templates, and then what benefits would we get from that? Would it be okay to summarize that? I know that's a big ask because it's a big monster, kind of.
Yeah, I'll try to summarize. So the idea of the templates is that basically all the contract scripts are basically put into the templates, and the templates themselves also contain the transaction shapes. So like what Audits got with the BitCANN diagram and all the descriptions of what the transaction structure actually is, that would all be in the templates, and then those are kind of invoked as actions. And with each action, what you do is you pass in the variables that you would actually need to execute that particular action. So an action is basically a sequence of transaction shapes. Might be more than one. Reason being, you need to, have sometimes like a token genesis transaction and things like that, or a consolidation transaction to make sure that you can conform to a later shape. But ultimately, the benefit of all this is that we can also get like human readable descriptions in these templates, so we can say this is what this action is doing, and it will actually feed in the actual parameters that are used in the contract. So you get a human readable description that can't really be spoofed. And ultimately the idea is to hash these templates, just a SHA-256 hash or whatever, and have trusted parties basically sign it and say, yeah, look, I've reviewed this. This, in my judgment, is doing nothing malicious. It's doing what it's supposed to. I can't see any vulnerabilities. And hopefully we'll have like not just, one auditor will have several, and a wallet might use like a quorum of trusted signing keys. It might be, Dagger has a signing key called Deep, Matthew, and GP. And, 3 out of 4 of those entities have signed for a particular template and said, yeah, look, this can't do harm. It's doing what it says it's doing. And, it's just generally safe. The descriptions are accurate. You get a very high degree of protection there. At the same time, it does come back to that issue that we discussed earlier. It's like, who do we get to actually do the audits themselves? That is a problem because it is going to be very high effort in a lot of cases. Look, I hope that made sense. I don't know. It's a bit hard to describe the templates exactly, and there's still
no, I think it's perfect, and I think it provides a great context for all this, right? Because once you have one of these templates that fundamentally encapsulates that whole BitCANN network of contracts, or a DAO, more generally speaking, a DAO, so forth, it encapsulates that whole concept. And once you have that, that's a much more complete picture of, this is a safe thing. Because if you just take this contract in isolation and say, okay, this contract is fine, and that contract is fine, this is a very famous thing in systems engineering, right? This one looks fine and this one looks fine, but you put them together and now you've got a new bug because they don't fit together the way you thought they were going to fit together. So, I think it's going to be helpful in the context of this safety and auditing and so forth to have the templates. I still don't think it's enough because you have to also have the tooling around it, as we discussed previously. But I think it's a huge part of the safety is having that integrated template where you can make assertions and make it clear that when I say I think this thing is safe, that it's unambiguously clear what I'm talking about, that it's this template, this network of contracts with this exact content, and not just a general thing like, oh, the BitCANN contracts. So I think the templates will fit very well into this audit and review and safety space of problems that we need to think about. All right. Thank you, Jim. And thank you to everybody. Did you guys, Kuldeep, did you have anything you want to add before we wrap up?
No. Thank you so much.
Okay. Dagger?
No, thank you, guys.
Yeah, thanks for,
I have one quick
joining, Matthew.
I have one quick thing I want to add, just because we talked about the safety of the different layers a lot. And so I work on CashCrypt, as you all know. So if there's any feedback on that layer, like things you would love to see changed or improved, or just some general thoughts, then we love to hear and discuss them. So for example, we see with the BitCANN system and with anything that's keeping a lot of state in NFT commitments, that it's not always clear from just the contract code what this state is, because the state might come from a reading state from a different contract and so forth. So multiple different contract authors have been documenting what the state looks like in comments. So just at the top of the file comments, and this is good for readability and documentation, but we're thinking about how we can standardize this in a way that it's part of CashCrypt. Whereas, for example, if you say this NFT commitment has 3 items inside it, and they may be of fixed length, and I can give them names. The first item is the user public key hash, then there is an amount that refers to a lock time, and then there is some third item that you can just refer to these items by their name, right? By their user-defined name. So this would be something like a struct that could be user-defined. And this example is just to say that we're thinking about ways to make it easier and safer for developers. And we're also looking at these advanced use cases and learning what are people doing, how are they using the language different from our expectations, or what workarounds do they need? So we're looking, but also we love to hear your thoughts and feedback, because I know there's many contract developers here in the space. I just wanted to say that again.
Yeah, my feedback is kind of along the lines that you're going, which is making it more convenient is good, but I would also say make it as strict as possible, right? And because you can always loosen things up, but as you pointed out with Solidity, when things are open ended and there's a lot of configuration and unknown magic going on, there's a lot of room for issues. So yeah, as strict and explicit as possible is what I would hope to see.
Mm-hmm.
All right, Jim, just in case, anything you wanted to throw in before we wrap up?
No, all good from my end. Yep.
All right. Well, thank you guys for joining. It was very good to talk with you, and I learned a lot from this discussion. I hope that people listening have also learned a lot from it, and it opened up a bunch of new things that I need to learn about and decide about and figure out how to move forward with general protocols in our contracts and wallets and so forth. So thank you guys so much for the time, and we'll talk with you again. Take care.
Take care. Bye-bye.
Thanks, everybody.
Bye bye. Thank you.